Alright, let's do example number 3. So there's two spheres of masses 3.2 kilogram and 2.5 kilogram fixed at point A and B as shown in figure 2, which I haven't actually added. I don't realize I forgot to include the figure, but I'll include it in your lecture notes later when I've uploaded it. So if a 50 gram sphere is placed at point C, determine the resultant force acting on it and the magnitude of the sphere's acceleration. Okay, so first let me draw the diagram. So the diagram is itu, terus ada sini point C punya. Okay, so dia ada line macam ni. Okay, boleh lah. Right. So this is point A, this is point B, this is point C. So the distance between mass A and mass B is 8 centimeter, whereas point C and point B is 6 centimeter. Okay, so this is 3.2 kilogram, this is 2.5 kilogram, this is 50 gram. Okay, so based on the question and as well as the diagram, the information that we have is the mass of A, which is 3.2 kilogram, mass of B 2.5 kilogram, and then mass at point C 50 negative 3 kilogram. Okay, lepas tu the distance between mass B and C is equal to 0.06 meter, and then distance between point A and point C, if we use trigonometry, remember 6, 8, dia punya hypotenuse is 10. If not, kamu boleh kira lah guna A square, B square plus C square semua tu. Okay, so this is 10 centimeter, which is 0.1 meter. Okay, so that is the information that we have. So now we have to consider the resultant force at point C. So in order for us to do that, we have to determine the arrow lah, dia punya arrow untuk point C ni macam mana. Okay, so for point C, the arrow for the force due to point A, due to mass A, is pointing towards mass A. Untuk points mass B pun sama, pointing towards point B lah. Okay, so this is FA, this is FB. Okay, now we have to resolve this into, we have to find the resultant force, and then if we look at this, we can see that this is actually it has an angle. The angle is here lah. Kalau ada angle, we have to look at these questions using X and Y component. Okay, so we are gonna resolve it. Okay, so now let's continue. The theta kamu boleh guna sin theta, which is equal to opposite over hypotenuse, so 6 over 10. Kamu akan dapat sin theta equal to 6 over 10, which is equal to shift sine 0.6, which gave us an angle of 0.6, 36.9 degree. Okay, so you will have that angle lah. Okay, alright, so now we have to look at this using X and Y component, right? So you can either do this on using a table, so X component and Y component. Okay, so we have force A, force B, and then this is the total lah. Okay, so this is force point A, and then force B, and then this is the force for X and Y component lah. Okay, so force at X component kita akan tengok FA. Sekarang kita mau resolve the 2D X component here. This is X, this is Y axis. So we will then get negative FA cos theta degree. Okay? Cos theta je lah, bukan theta degree. Alright. So this one pula untuk Y component, dia akan pointing downwards. So sama juga, negative FA sin theta. Okay. Lepas tu, let's look at point B. Since this is 90 degree to the horizontal component, Y component, X component dia akan equal to 0. Okay. So now the Y component pula, since it is pointing downwards, it will be negative. Then it lies on the Y component, so they're just negative FB. Alright. So add those together. So you should get the force at X component to be equal 8.56, 10 negative 10 Newton. Untuk Y component pula, you should get negative 2.96 times 10 negative 9 Newton. Alright? Okay, after that, yang untuk cari value FA dengan FB ni, kamu guna the gravitational force punya formula lah, okay? Which is GM AMB over RAB square. Okay, yang force at B pun sama jugalah, guna the same formula. Tapi this time untuk RB dengan C lah, RBC. Okay, right. So after that, we can now find the resultant force lah. So the resultant force is Fx square plus Fy square. So you should get the value of 3.08 times 10 to the power of negative 9 Newton lah. Alright. Right. Now we can do the direction. Since this is a vector quantity, we have to find the direction lah. So this is just shift tangent y over x, which is negative 2.96 times 10 negative 9 over dengan negative 8.56 10 negative 10. Okay, so you should get the angle to be equal to 73.9 degree. Alright, so that is how you find the resultant force. Then we have to find the magnitude of the sphere's acceleration. So this one, you can just use the circular motion punya formula, which is total force equal to MAC. Okay, so we have the net force, which is equal to 3.08 times 10 to the power of negative 9, which is equal to the mass. So for this one, we are gonna use the 50 gram punya mass lah, sebab we are now looking at this 50 gram punya sphere. Okay, so 0.0123 kilogram. So you'll get, this is the acceleration. So you should get the acceleration to be equal to 6.16 times 10 to the power of negative 8 meter per second square. Okay, so that is how you solve for example number 3. I mean, if you come across this type of questions where you have to find the resultant force and then it is at an angle, you should look at it. You should look at the x and y component lah. Okay, and then make sure you also calculate the direction. And then if they ask you to find the acceleration, you can use chapter 6 punya formula saja lah, which is the centripetal force equal to MAC. Alright, okay, so that's for example number 3.